Okay, see Lindelof. I was asked to continue this discussion on continuity, so I thought we'd talk really quickly about continuity of a function. So I'm going to try to keep it in less than 5 minutes, so bear with me and hopefully I'll do a good job. So here, the idea of discussing the continuity here. Is this function continuous? If f of x is equal to 1 over x, is it continuous? And if it's not, how can we describe why it's not continuous? Well, this function is not continuous, and one way to look at it, to be able to see it, is to just kind of draw a little sketch of what this function might look like, or what it does look like, and it looks a little bit like this, doesn't it? So if I take this function, it kind of does this, doesn't it? And it kind of does this, doesn't it? So we have this function, and we can see as x approaches 0, we have a domain issue, right? We have a problem, and we have what's called a vertical asymptote here, that x is equal to 0. And what happens is we see as x approaches 0 from the left-hand side, look what happens. The function goes like this, and it starts getting pressed down really hard right here, right? It's never going to get to x is 0. And then if we look at this function as x approaches 0 from the right-hand side, well, then it looks like this, doesn't it? It goes like this, and it goes up, infinitely up, and again, it's never going to touch 0. So we can see here that from the right-hand side, as we make this right-hand approach and go up, this function heads to infinity, right? As we make a left-hand approach, the function starts to dip down to negative infinity. So we can see that this function is not continuous. This function is not continuous at x is equal to 0, right? And we can use one of a number of arguments. The one I like is that the limit of, and now I'm going to say why. I'm going to say that this limit fails because the limit of f of x, this function up here, right, as x approaches 0, fails. And why does it fail? Because we know a limit has to approach the same height. If you look at the orange part of the function, it's approaching this maximum height, this enormously big height here. And if we look from the left-hand side, we're approaching this enormously small value. And remember, enormously small in calculus means very, very large negative numbers, not approaching 0, right? Okay, I think we have time. Let's look at this one really quick. Here's the second function I wanted to look at. We say, well, what if we have this function g of x, and g of x is equal to x squared minus 1 over x minus 1. Well, we can see this function has some problem at x is equal to 1, but I wonder if you can see this. I can take this, because this one is not quite as clear. But if you look at this function, I can break this. This is difference of squares, so I can break the the numerator out to be x plus 1 times x minus 1, right? And then this denominator can't be factored, but it works out well, doesn't it? X minus 1. Well, you say, okay, well, this cancels. So we can say that g of x is equal to x plus 1, but we know what the original was. We know what the original function was, and we have to keep that in mind. So this function, which looks really complicated, turns out to be a relatively simple linear function, doesn't it? And it has its picture looks similar to this, right? So it looks like this, and I'm just going to graph this, and that looks something like this, doesn't it? I'm not going to do any points here. However, the one thing I do know is that at this point right here, this is the point, right? This is the point 1, 2. The function is discontinuous, and there's a break, right? It's called a hole in the function, but remember that continuity has to do with not being interrupted and not being broken, and there's a break here. So that's my discussion of those two functions. That this function is on an open, on the interval negative infinity to positive infinity, this function is not continuous, right? It has a specific discontinuity. And this one, this f of x function up here, is also not continuous because the limit fails. And we talked about continuity at a point in the last video. And if you haven't seen that, I'm begging you to go back and watch it. Because we need to really kind of just have this off the top of our head. So when we're sitting down for that AP exam, this stuff needs to just flow over. So we're like, okay, yeah, this is no problem. I get how they're getting to me on that. All right? Hey, thanks for watching. If you have any questions, I'd love to answer them, or any comments, anything you think I can do better. And if you haven't already subscribed, please subscribe. Thanks, you guys.